Okay, so in today video we will in the previous video we have covered the different types of the the controllability test. So in order to understand the controllability test we have seen the different types of cases of number one, that is the Kalman test. We have derived the Kalman criteria for the controllability, that is the QC, the matrix QC determinant of the QC, the composite matrix, the determinant of the composite matrix not be equal to the 0, or you can say the rank of this matrix QC should be the full order. Okay, second one was the Gilbert test. Okay, the Gilbert test we have to cover this Gilbert test, and third is also that the PBH. We will see what is the PBH, the PBH test. Okay, so one by one we have covered the Kalman test. Now it is time to understand the Gilbert test. So before going to the detail of the Gilbert test, because in the Gilbert test we use generally the canonical form, right? Diagonal canonical form. Okay, so first of all we have to understand the canonical. What are the different form of the canonical? Okay, canonical form. So in the today video or today lecture, we will try to understand the different types of the canonical form, or you can say the transfer function, and state model canonical realization. Canonical realization. It is the topic of the discussion today, right? So, what are the different types of the canonical form? If you understand, so first one is what is the canonical form. We will cover today, and what are the different types of the canonical form. First one is the controllable canonical form. Second one is the observable canonical form. Third one is the diagonal canonical form, and fourth one is the Jordan canonical form. Okay, so first of all we will try to understand what do you understand by the canonical form, what is the need of this canonical form, and then we will understand, we will drive one by one, we will try to understand one by one the controllable canonical form, observable canonical form, diagonal canonical form, and the Jordan canonical form, right? So first you can say that a state model obtained, right? A state model obtained for a system, for a system is unique or non-unique. What is the suppose that you have the state variable, different choice of the state variable. So is it possible, what about the uniqueness of the state model? Is it unique or non-unique? Anyone can tell me?
Not
For a system,
non-unique.
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 Okay,
Non-unique.
is not unique, right? It is not unique. It may be the different. Okay, it depends on which criteria. It depends on the choice of a state variables, right? Second one, we can say also for a given system, many state model, yes or no? Many state models can be derived, yes or no?
Yes, sir.
Can be derived, representing the same system, representing the same system. For the single system there are too many methods, there are so many methods in order to represent that system, right? Okay, another thing, given the transfer function given the transfer function of a system, right? For a single transfer function, okay, let's say we have any transfer function y s upon rs, right? So it has a different types of the representation also. Okay, you can write here many state models. We will see many state models can be realized can be realized using different techniques, right? अब आप मुझे बताएं, जरा ध्यान से देखें क्यों जरूरत पड़ता है कैनोनिकल फॉर्म का। तो आंसर ऑफ द क्वेश्चन इज हिडन हिडन हियर। आप इसको देखिए, फॉर एन nth ऑर्डर सिस्टम, ध्यान से देखना, फॉर एन nth ऑर्डर सिस्टम, what is the order, what is the matrix, what is the order of the matrix, the system matrix, please, the system matrix is out of order, system matrix is of order, please tell me, of order n cross n
N
होगा
cross
भी या
N.
नहीं होगा?
N.
ध्यान से बताओ, n क्रॉस n होगा या नहीं होगा? n क्रॉस n, ठीक है। अब आगे
Yes, sir.
चलते हैं, ध्यान समझिएगा इस बात को। आगे, इफ देयर आर p input and q output, q output, wait a minute, okay, q output, p input and q output, देन इनपुट मैट्रिक्स, जो इनपुट मैट्रिक्स है क्या है बेटा? ए बी सी डी, है ना। तो आपका एक तो आपका स्टेट मैट्रिक्स हो गया ए, या सुनो, इनपुट मैट्रिक्स कौन सा है बेटा? बी,
B.
या सुनो। तो
N cross P.
इनपुट मैट्रिक्स, यस, इनपुट मैट्रिक्स इज ऑफ ऑर्डर, प्लीज टेल मी व्हाट इज द ऑर्डर
N
ऑफ
cross
दिस?
P. N cross P.
n क्रॉस p, वेरी
N
गुड,
cross P.
n क्रॉस p, okay, good. And what about the, and what about the output matrix order? Output
So C
matrix C
matrix का P
is
cross N.
of order, huh?
Sorry, Q cross.
Q cross
Q cross N.
n,
Q cross N.
very good, Q cross n, ठीक है, n cross n ये हो गया, n cross p, this is the Q cross n, very good. Okay, now last question, my last question is the input, sorry, the input and output, the input and output coupling matrix, that is the D, remember, D matrix is of order, उसका क्या order
Q
होगा?
cross P.
हाँ,
Q cross P.
very nice, very nice, very good, Q cross P, very good, Q cross P, ये हो गया आपका टोटल। यानी ए बी सी डी मैट्रिक्स का आपने सिंपल सा ऑर्डर सबने लिख दिया, दिस इज फॉर द ए, यस और नो, दिस इज फॉर द ए मैट्रिक्स, दिस इज फॉर द बी मैट्रिक्स, दिस इज फॉर द सी मैट्रिक्स, सॉरी ए मैट्रिक्स, ओके, बी मैट्रिक्स, सी मैट्रिक्स एंड द डी मैट्रिक्स, राइट, ओके। सो नाउ वी कैन कंक्लूड हेयर कि हेंस नंबर ऑफ एलिमेंट्स, आपको बताना है number of elements in A, B, C and D matrix will be, कितने होंगे? is equal to anyone, anyone, number of matrices, number of elements in ABCD कितने होंगे? A में कितने एलिमेंट होंगे? प्लीज टेल मी।
n square.
So N
n
multiple
स्क्वायर,
by N.
वेरी
N
गुड, n
square.
स्क्वायर, क्योंकि n ऑफ n ऑर्डर का है, देखिए n रो n कॉलम का है, तो टोटल नंबर ऑफ एलिमेंट कितने हो गए? n स्क्वायर,
N
सो
square.
n स्क्वायर।
Yes.
व्हाट अबाउट द B, n क्रॉस
N into P.
P, यस और नो, np
Yes, sir. NP.
plus
Plus
qn
Q1.
plus qp.
Q
This is the
and
number
QP.
of total number of elements including A, B, C and D. बोलो ठीक है कि नहीं? टोटल नंबर ऑफ ये हो गया, या सुनो, या
Yes,
सुनो,
sir.
okay.
Yes, sir.
So this number, you can say this number is very large, very large, and can be significantly, can be significantly reduced. ऐसा है कि for the simulation purpose, okay, at the time of simulation you have to enter A matrix, B matrix, element of the ABCD matrix, right? So it may be, there are maybe the different representation by which we can represent the same matrix in another way, और यू कैन से इट इज, और दूसरे तरह से समझ सकते हैं ऐसे कि चूंकि ये नंबर बहुत ज्यादा है, इसलिए हम इसको मे भी इसको हम घटा सकते हैं. कैसे घटा सकते हैं? सिग्निफिकेंटली रिड्यूस्ड. ओके, बाय, और रिड्यूस करेंगे इस तरीके से कि उस पर कोई फर्क नहीं पड़ेगा, सिस्टम पे कोई फर्क नहीं पड़ना है, उसी का रिप्रेजेंटेशन है, बट दैट द रिड्यूस्ड फॉर्म में, राइट. बाय ड्राइविंग state model from the transfer function using certain standard, right. आपको स्टैंडर्ड, you have to follow the standard and accepted procedure और methods, राइट. तो स्टैंडर्ड मेथड, एक्सेप्टेड मेथड से आप उसको रिड्यूस भी, अगर ऐसा पॉसिबिलिटी है तो ज़्यादा अच्छा है कि उसको रिड्यूस कर दिया जाए, नंबर ऑफ एलिमेंट्स को घटा दिया जाए, बाकी सब जीरो जीरो कर दिया जाए, मैक्सिमम नंबर ऑफ द एलिमेंट्स को जहां उसकी जरूरत है. इज इट क्लियर?
Yes,
इज
sir.
इट क्लियर? So you can say here such a state model with matrices having minimum number of non-zero, जहां जरूरत है मिनिमम नंबर ऑफ, सबको मैक्सिमम को जीरो कर दो, मिनिमम नंबर ऑफ को नॉन जीरो रखो. ठीक है, ये जो टेक्निक्स है इसी को कहते हैं हम लोग कैनोनिकल फॉर्म. अगर ऐसा पॉसिबल है, मिनिमम नंबर ऑफ एलिमेंट को नॉन जीरो हमने कर दिया है, इट फॉर्म वी आर एबल टू रिप्रेजेंट दिस फॉर्म इज अ कैनोनिकल फॉर्म. So what are different canonical form? Please tell me now. First one is the controllable. मैंने बताया था कुछ दिन पहले.
CCF.
Controllable, yes,
Controllable.
canonical form. Very good. CCF. Second one is the
OCF.
observable.
OCF.
Observable canonical form, OCF. Right. Third one is the
Diagonal.
diagonal canonical form, that is the DCF. And
Yes, sir.
fourth one is the
JCF.
Jordan canonical
Jordan.
form, that is the JCF. Right. याद रहेगा?
Yes, sir.
So now
Yes, sir.
we will try to understand one by one, right? So it is the introduction of canonical form.